Our goal in this classwork is to combine things that are not over common denominators. So the first thing we're going to have to do is figure out what the common denominator is going to be, and then we're going to have to create equivalent expressions from what we have by multiplying by something over itself. Then we can combine the things once they're over a common denominator and simplify. So here my denominators are 3 and 5. If I start with 3 and 5, 3, 6, 9, 12, 15, 5, 10, 15, 20, 25, 15 is the least common denominator between these two. So I want to turn x over 3 into something over 15. To do that, I'm going to multiply by 5 over 5. I want to turn 2x over 5 into something over 15, so I'm going to multiply by 3 over 3. X times 5 on top gives me 5x. 5 times 3 on bottom gives me 15. 3 times 2x on top gives me 6x. 3 times 5 on bottom gives me 15. I've gone from two fractions that did not have a common denominator and could not be combined to two fractions that do have a common denominator and can be combined. So we keep it over that same common denominator. Over the first term was the 5x, over the second term was the 6x. So when we combine them, we get 11x over 15. At this stage, I want to see if anything can be reduced between the 11 and 15. It cannot. So this would be my final answer to that problem. In part B, if I start making my list for 7, 14, 21, 28, 35. For 14, it'd be 14, 28, 42, 56, and 70. You can see that 14 is the first thing that overlaps on both lists. I already have 14 as the common denominator of my second term, so I just need to change my first term by multiplying by 2 over 2. 2 times 3x gives me 6x. This plus x is still over that same 14. When I now combine the like terms on top, 6x plus x gives me a total of 7x, still over 14. I can take a 7 out of each thing. So on top, I really have 7 times x. On bottom, I have 7 times 2. When those 7's go away, I'm just left with x over 2 as my final answer. In part C, it's a little bit trickier to find the common denominator. Here, this is really just an understood 1. This is a 4, so I need to multiply by 4. I also have to look at the variable. Here I have an x squared, here I have an x. I want the highest power of the variable, so really my common denominator is going to be 4x squared. To get the first term to 4x squared, I'm going to multiply by 4 over 4. To get the second term's denominator to 4x squared, I'm going to multiply by x over x. 4 times x plus 2 over x squared. 4 times x squared gives me 4x squared. On top, I'm going to write it as 4 parentheses x plus 2. Then I'm going to add to that. On bottom, 4x times x gives me 4x squared. On top, I have x times x plus 1. If I keep going with this, 4 times x plus 2, 4 times x gives me 4x. 4 times 2 gives me 8. This is all over the common denominator 4x squared, but now I'm going to combine this side as well. X times x gives me x squared. X times 1 gives me x. When I combine like terms, this x and this 4x can combine. If I write things in the order that I'm used to seeing them in decreasing powers of x, it would start with x squared plus 1x and 4x combined to give me 5x plus 8 all over 4x squared. It's a good idea to try and factor the top at this point, see if anything can cancel. In this case, there's no way to factor x squared plus 5x plus 8. The only way to factor the 8 are 8 and 1, 4 and 2, neither of which add to 5. So we would stop there. Here in number 2, A and B, we're doing the same general idea, just for a slightly more difficult type of problem. So in this case, when I have factors like x plus 5 and x minus 2, I basically want to see if I can factor them further to see if there's any overlap. In this case, there's not. So I just need to multiply one factor by the other. What I mean by that Here I have 3x over x plus 5. I'm going to multiply it by x minus 2 over x minus 2. Here I have x minus 1 over x minus 2. I'm going to multiply it by x plus 5 over x plus 5. When I do this, on bottom, I'm going to have, for each of these fractions, x plus 5 times x minus 2. On top, I've got to do out my multiplication. 3x times x gives me 3x squared. 3x times negative 2 gives me negative 6x. X times x gives me x squared. X times 5 gives me 5x. X times negative 1 gives me negative 1x. So 5x minus 1x gives me 4x. Then I have this negative 1 times that positive 5 to give me minus 5. If I clean this up by combining like terms, 3x squared and x squared give me 4x squared. Negative 6x and positive 4x give me negative 2x. And then I have negative 5. On bottom, I have x plus 5, x minus 2. I would leave it right here. It is a good idea to try and factor this top, possibly. Honestly, it might even factor, but I can see that neither of the factors is going to have the single term of x plus 5 or x minus 2, I think. Let me actually do it out just to see if I can factor it. So if I do it out with the cross method, 4 times a negative 5 is negative 20. Bring down the negative 2, so I'm looking for two things that multiply to negative 20 and combine to negative 2. 5 and 4 would be the closest thing that I have. Negative 5 and positive 4 would get me to negative 20, but it would give me a negative 1. Otherwise, it'd be 10 and 2, which doesn't do anything for me. There's no way to factor this, so I can definitely stop there. When I look at part B, hopefully I can recognize that these are very similar. There's just a slight difference. The slight difference is a negative sign. Basically, if I multiplied this whole bottom by negative 1, I'd get to that bottom. So what I'm going to do is pull a negative 1 out of this. When I do that, it's going to become 3c over negative 1. When I pull a negative 1 out, it's like dividing by negative 1 here. Positive divided by a negative gives me a negative d. Negative c divided by a negative 1 gives me a positive c. I can then see this second equation as plus and apply that negative to the bottom. So plus 3d over applying that negative to the bottom, negative c minus d. So somewhat tricky how I got there. There's a lot of different ways to see it. You don't have to mess with this negative sign if you don't want. You can just change this to c minus d, multiply this by negative 1 over negative 1. All that's going to do is make that a positive 3d, make this bottom have that negative on the outside. So there's other ways to get there if it's confusing how I got there, but this is where I need to end up, where I can then say, well, they're all over negative c minus d. I'm going to take the top of this one, 3c, add the top of this one, 3d. I can take a 3 out and make it c plus d, but that's not going to reduce with c minus d anyway. So even though there are ways to rearrange this, I don't think I need to do it for Cengage. I think it should mark this answer right. If I wanted to go the extra step, I could call it 3 over c plus d divided by negative c minus d. Continuing on with these classwork problems, part C also is an instance where I just really am trying to recognize that this denominator and this denominator are the same except for a negative sign. So basically, if I multiply this fraction by negative 1 over negative 1, then what's going to happen is the first fraction stays the same, 8 over b minus 6. The second fraction, what used to be a positive 12, becomes minus 12. What used to be 6 minus b becomes negative 1 times a positive 6 is negative 6. And negative 1 times a negative b is positive b. So both of them now say b minus 6 on bottom instead of a plus. this is a negative sign. Again, I got there really by multiplying by -1 over -1. If I now combine these over the common denominator of b minus 6, I get on top 8 minus 12, which gives me -4 over b minus 6. Can't reduce that any further, so I end there. Part D, same general idea. The t squared minus 9 and the 9 minus t squared are the same if I just multiply by a -1 in the second fraction. So -1 here, -1 here. What that means is the first fraction, t plus 3 over t squared minus 9 stays. When I do 6 times a -1, I get minus 6. When I do -1 times positive 9, I get minus 9. When I do -1 times a negative t squared, I get positive t squared. Now I can combine them over the same fraction. When I do t plus 3 from the first and then minus 6 from the second, it's all still over t squared minus 9. On top, t plus 3 minus 6, the positive 3 and the minus 6 combine to give me t minus 3. But hopefully at this stage I recognize, well wait, this bottom is a difference of squares. T squared minus 9 can really be written as t plus 3, t minus 3. Once I write it right like that, I can see that I have a common factor on top and bottom, specifically these t minus 3's. That means there's an understood 1 that stays on top. On bottom, the t minus 3 goes away, but the t plus 3 stays. So this is the correct final answer to that original problem. Parts E and F are a little trickier. Basically, they require me to factor everything to begin with and say what's missing from each of the terms. What I mean by that, I can't factor x plus 2 anymore. I can't factor x minus 2 anymore. But I can say that x squared minus 4 is a difference of squares. It's really x plus 2 times x minus 2. So what I want is for all of these denominators to be x plus 2 times x minus 2. This one already has it, so I don't need to multiply by anything to get this over the correct denominator. E only has the x plus 2, so what it's missing is an x minus 2 that I need to multiply the top and bottom by. 5 over x minus 2 already has the x minus 2, so what it's missing is the x plus 2 that I have to multiply top and bottom by. The first term then becomes x minus 2 on top, x plus 2, x minus 2 on bottom. The second term becomes 5 times x is 5x, 5 times a positive 2 is a positive 10, also over x plus 2, x minus 2. Finally, this minus 3 has not changed. It's still minus 3, and it's still over x plus 2, x minus 2, which it was already over. Since all three of these are over the same common denominator, I can write them as a single fraction over that common denominator of x plus 2, x minus 2. The first term, x minus 2, goes here. Then I add to that 5x and 10. Then I subtract from that 3. When I go to combine like terms, this x and this 5x are like terms. They give me a total of 6x. This -2 and this -3 give me -5. When I add that to 10, I get positive 5. So I wind up with 6x plus 5 over x plus 2, x minus 2. I'd want to check, and if, for instance, this had been 6x plus 12, I could pull out an x plus 2 that would cancel. In this case, 6x plus 5 doesn't really do anything for me. There's no common factor, so I would just leave it right here. Same kind of math is going to apply down on part F. I'm going to start by looking at the denominators and saying, how can I factor this denominator? Well, I'd have two parentheses, x and x, bring down the negative sign. That tells me same as a negative is another negative. Now I'm looking for something that multiplies to 3 and adds to 4. So the only way to multiply to 3 is 1 times 3, which does add to 4. I'm going to put the 3 here. I'm going to put the 1 here. Notice it's exactly what's under the other two terms. It's probably a good hint if you look at the other ones to say that, all right, this x squared term probably factors to what the other ones are, because that's how these formulas usually work out. That said, it's not necessarily true that they're always going to equal to that. So you do want to check, but these are good hints for how to start your factoring. I have the x minus 3 and the x minus 1 already in this term. In this term, I have the x minus 3, but I need the x minus 1. In this term, I have the x minus 1, but I need the x minus 3. So what that means is these are all going to be over that same common denominator of x minus 3, x minus 1. When I deal with the top of this fraction, nothing is being multiplied, so it can just stay as 4x. When I deal with the top of this fraction, 4x times x gives me 4x squared. 4x times a negative 1 gives me negative 4x. When I deal with this fraction, that negative and that 2x have to be multiplied by each thing in the parentheses. So negative 2x times x gives me negative 2x squared. Negative 2x times negative 3 gives me positive 6x. If I now combine the like terms on top, positive 4x squared minus 2x squared leaves me with positive 2x squared. Positive 4x minus 4x, that leaves me with no x's, and then I have 6 more here, so I have a total of positive 6x. All over x minus 3, x minus 1. Last step, I'm going to factor the top. I can take a 2x out of each term. If I take out that 2x, I'm left with x plus 3, all over x minus 3, x minus 1. This was close to a factor that was the same on top and bottom, but since this is a minus and this is a plus, they're not the same, meaning this is as far as I can go and I would have to leave it there. But do know if something did cancel and you didn't find out that it canceled, your previous answer would be wrong because it's not simplified in its most simple form.